Question 2 for pHs of strong acids and bases just gives your calculator a little bit of a workout without too much difficulty beyond that. Most of these equations are given on the calculation sheet or on the formula sheet. You just need to know when and how to use them. So strong and weak, or excuse me, strong acids and strong bases is what you want to see on both the multiple choice and the free response, because whatever the concentration of your acid, that's the concentration of hydronium and hydroxide ion. So we are given that molarity right there. If this is a multiple choice, you might have to ballpark some of these figures. So being able to round and estimate these numbers is important. Then we know from the KW expression how to get from hydronium to hydroxide. The pH is the negative log of that. And one of the things from the video describing how to estimate these, if this is to the negative third, I'm going to be somewhere between 1 to the negative second and 1 to the negative third. Well, that's a pH between 2 and 3, which is how we were able to estimate or know that something in the range of 2 point something makes sense. We could do the same thing with our OH to our POH. The other thing we can know is that pH plus POH equals 14. So getting from one piece to the next, there's often lots of options depending what makes the most sense, or what makes the most sense depends on what you're asked. If you're asked to get from H plus to POH, you could either go pH to POH or you could go OH to POH. Both are great. So just a little bit of repetition with this is really good. On the second example, almost the exact same things, but recognizing two things here. One, we have a base, so we're going to be given hydroxide concentrations. And secondly, when we do have that little subscript, especially on our strong bases, we can know that that dissociates to form 2 hydroxides for every mole of strontium hydroxide, which is where the 0.82 comes from. We solve for hydronium, we solve for pH, we solve for POH, and do note that it's possible to have pHs really close to 14 or even above. POH is really close to 0, and it is possible, at least mathematically, to go below 0 for a pH or POH and above 14 as well. On these examples here on B and C, it's just going the other way. What I want to point out here is significant figures. We have 3 digits after the decimal place, which is why our concentrations each had 3 significant figures. Here we have 3 significant figures, which is why there's 3 digits after the pH. In each of these, there's different ways to solve it. And significant figures are not the most important thing, but it is something we can practice and learn and make sure that we don't make that mistake. So coming back here, we have a similar idea. 3 digits, 3 digits, 3 digits in our concentration led to 3 digits in after the decimal in our logs here in our pH and POH. 2 digits and 2 digits led to 2 after the decimal when we did logs. So hopefully these are all really easy. Just memorizing your strong acids and bases and knowing when and how to apply these equations is super important.